Hi, everyone, and welcome to walk through another one of my applications, the Brain Tumor Classification Machine Learning Model app. So for context, even for a very highly skilled and experienced neurosurgeon, it can be very difficult to identify and classify a brain tumor from a single MRI scan. And that's where machine learning can come in. I've trained two machine learning models to identify and classify brain tumors from a single MRI scan, and it'll classify across three different types: meningioma, glioma, and pituitary. And so this will free up lots of time and energy for neurosurgeons and provide them a powerful tool to use when diagnosing patients. So on this web app, this is deployed live right now at brain-tumor-ml-stone.streamlit.app. We're first prompted to upload an image. So this image we will upload has to be an MRI scan of a brain. And for instance, I'll upload an image of a glioma. And right now what the model is doing is scanning the image, excuse me, and identifying whether there is a tumor, and if so, which type. So we've come back with the results now, and it looks like according to this saliency map, which visualizes where in the image the model was gathering most of its data, it shows that the most of the data, the information, it was on this left half of the image. And again, I'm no neurosurgeon, but this easy visualization allows anyone to understand what might be happening based on the MRI scans. So we have this prediction and confidence rate, and we also have an explanation in natural language. So it looks like the saliency map highlights a region of abnormal tissue in the right parietal lobe, and that's common for gliomas, and there's a high confidence score. So that seems pretty straightforward, and this was using the exception model. So that was a pre-trained model that we further tailored towards MRI scans with some more training. And this is a very accurate but very large and heavyweight model. So in places where hospitals or healthcare professionals maybe don't have as much computing firepower, they might be more inclined to use a custom CNN model that I created with many fewer neurons, and thus it takes a lot less computing power to run and can run on much simpler hardware that would be on someone's normal laptop. So we can try it again with a custom model and a different image, and this time we'll use no tumor. So, and this is running, and again, it was super fast, super lightweight. And so as we can see, the saliency map shows that we were looking at data kind of all across the brain, and we found that there's no tumor, the 99.5485% confidence. So if there was a tumor, which is very, very unlikely, the only thing it seemed to be looking at was a meningioma. As the explanation reads, the map highlights areas along the periphery, which correspond to the skull, and there's not anything indicative of tumor growth. So this tool, this machine learning tool, can be a huge help to healthcare professionals um, when diagnosing many patients, and because it can be difficult from a single MRI scan. So if you'd like to try it out, you can go to brain-tumor-ml-stone.streamlit.app and try it for yourself. And in the description, I'll link below the open source GitHub repo I used to train these models. And thanks so much for watching.